Yo, what's up, everyone? We're back at it with the second project. So this is going to be the project example. Um, and quickly, all that's going on is we finished unit number 2, and we're going to have the test next week. But for problem set 2 this week, I'm going to assign you the project. Now, I'll give you till next week to do it because some people think, and then honestly, I think the project's probably the most time consuming thing we do. Um, but yeah, I'm going to show you the project and I'm going to go through it step by step, just like the first video project. And from the feedback I got, the first project was difficult, no doubt about it, but everyone who watched the video said it was really good. And like, very quickly, I want to say I'm really, really proud of the projects. Like I did this last year too, the same project, and somehow the projects were even better this year. So I think the video really worked, but we're going to do it again. Kind of to sneeze. Okay, so yeah, this is what the project's going to look like, and we're going to build to this. But know that all we're trying to do is create a scatter plot and then also a residual plot. Um, and I'm going to send this out. This is project number 2. But let's go from the very beginning. And we're going to start in the exact same place that we started the first project, and that's with 2 data sets. Okay? And before I do anything else, let me just say this. A lot of students found collecting data to be the hardest part of the first project, and I think that, that's really valid. So this project, you don't need to collect new data. The first project, I honestly set us up for success with the second project. The second project should be way quicker because we've already collected 2 data sets. Okay? So if you would like to use the exact same data you did the first time, you can. But if you collect new data, I will give you extra credit. Okay? I'll give you 4 extra credit points, so like 20%. And that's because I think collecting data, while maybe not like an AP skill necessarily, is like a cool life skill. So your first step is to collect your data. And I found, I'm talking about air quality in mine. I don't really know that much about air quality stuff, but I found it took me like 2 hours to collect my data. So it's normal to take a long time to collect your data, but I found this from the Lung Association for how many days they have terrible air quality, and then how big each city was. So my data is the biggest cities in the US, their population, and how many days they had terrible air quality or really high ozone rate. And the first step is going to be really easy. What I want to show you first is, like, remember in the first project, you have a single data set and the first unit, right? So if I wanted to do something with a single data set, like make the chart for it, all I have to do is take these rows, highlight them, and do chart. And it takes so long when I'm screen recording. It doesn't always give you the chart you want. I prefer something more like that from the first unit. Wait, give me a sec, because they should be connected. Okay, yeah, so that would be the first unit, right? That's what we did for the first unit. But remember that all the second unit of the class is every data point now has 2 pieces of information about it, right? A scatter plot talks about all your cities, not only tells you how many days they had bad quality, air quality, but also their population. So the first step of this project is going to be really easy, and we're just going to start right away by making a scatter plot. So I'm going to take my rows, highlight them both, and if I insert chart while highlighting both of these rows, and then look for scatter plot or scatter chart, we're going to get our data, like the chart we want. I need to move my face. I'll go here, because once we have our chart, we know that a important part of this unit is like customizing it. And the big customization I'd want on this is to make sure that it gives me my line of best fit. So to do the line of best fit, you go to Series, and just click trend line, and it's going to go. Now, because I labeled it, it already gave me my labels, but you need to make sure that you have both your X and Y labeled and then a label for your whole graph. And my label for the whole graph is just going to be US cities and air quality. So that is step one. And I'll put that down here. We have our chart, but now we want to kind of do some analysis of my scatter plot. Okay. So now I guess we're in part two. And part two is always the statistics, right? So we're going to find some correlation statistics here. And this is going to be super similar to what we did last time. Instead of finding like the median, the mean, the range, that kind of thing, we know that for a scatter plot, all we need or all we know is the line of best fit and R, okay? So to make our line of best fit, we're going to do it two parts at a time. We're going to find the slope of the line and then also the y-intercept, okay? And if you were good at it the first time, it's not going to be hard. If we want to find the slope of the line of best fit, we do equals slope. And then you do y, then x. And that's really, really important. Y, all of your data, and then we want a second set, so we do comma. And that's going to give me my slope. In this case, it's a really small slope, which is going to be a little hard to deal with, but you know, your data might be really wacky. But again, whenever you want to find a statistic on Google Sheets, you're going to press equal and then some sort of key phrase. And I give you all those phrases in the video. Y-intercept is just intercept. The same concept. So I have my slope and my y-intercept, and I just want to write them in an equation so that we can visualize it. Okay, so there's no way to calculate it other than to just write it. Y equals 0.00000124 x minus 60.45, because we know the line of best fit is in y equals mx plus b, so y equals slope x minus the intercept. So we're already halfway done with the statistics and almost getting there with the project. That's my line of best fit. And I want to format it, so I'm going to just put it to the other side. And then the other big thing is R, right? We know we have R and we have R squared. And to find R, you may have been able to do this on your own, but we're going to find the correlation, and it calls it the Pearson product moment correlation coefficient. You don't need any of those words, but we're looking for correlation, and the same concept. So you should always think y, comma x for all of these, and it gives us a number. And we got a decimal, so we know we're doing the right thing. And instead of trying to find a new one, we know that r squared is literally this number squared. So we'll do r square root of that number. Let me do that one more time. If you ever want to find like a calculation for a specific number, first positive square root of a positive number. So we want to find the square root of this particular number. So we click it and it gives it to us. So I now have r and r squared. And let's just, what did I say on my project? Let's just put it in words. If we're looking at my scatter plot, it actually doesn't look nearly as strong as R suggests, but that's fine with me. And I'm going to describe it as very strong positive. And I know it's very strong positive just from R. Okay, so again, you pretty much have to understand the unit to dominate the project as well. But correlation, if we wanted to describe it in words, always comes from the R value. So if R was 0.86, we know that's a really high correlation coefficient. So that's how you could find every statistic on Google Sheets. And we have a scatter plot. But we have one more thing that we're going to do that I don't want it to show that. Yeah. One more thing that we're going to do that I think is maybe the hardest part, but should be really fascinating. Okay. And I'm really trying to get you to learn some of these Google Sheet skills. Um, so let me tell you how we're going to do this. What I want to do is make a residual plot. That's my goal. But the way I'm going to do it is I'm going to try to calculate the residual for every point. Okay? We know that the residual plot measures how far away every point is from the line. So all I would need to do is create another row that has all the residuals, and then I could graph it. That's like the big idea I'm thinking, and this is kind of similar to the last problem set I sent out this week. But I'm trying to find every residual. But to do that, I need to figure out what's expected, right? So I'm going to create a row of all the expected values for all of my data points. Okay, so I'm going to say expected number of days. And again, what I'm trying to find is for each of these points, what's expected. So this first point, like New York City had 315 days that were bad air quality. But I really want to figure out what the expected value is, or what it equals right here. Okay? And here's how I'm going to do this. This is the hardest part of the whole thing, and I think it's fascinating. If I want to figure out what's expected in New York City, all I need to do is plug x into my equation, right? Because we know that this line of best fit, y equals the small slope minus 60, tells me what's expected. So I'm going to plug this value into my equation using Google Sheets. Okay, and I'm going to do it really slowly. But the equation is y equals mx plus b. So this equals y, this expected value equals mx. So the slope times our x value. The slope, we're going to click on it, times x plus b. mx plus b. Slope times x plus b, and equal. Now that we did it, let's confirm that this is correct. 219. And on my chart, that's what's expected right there, right? That makes a lot of sense. Again, all I did here was I took my x value and plugged it into the equation. Y equals mx plus b. Now, we could do this for every point, right? We could do equals this times this plus this. And it's going to work every time. But I'm going to try to show you a shortcut, which is going to like continue to elevate your game on here and how good you can do Google Sheets. And that's by dragging. Okay. So I can actually go. So one really cool thing about Google Sheets is that a lot of times you can do things without plugging in formulas constantly. If I drag this down, okay. So the way that we can do this is by dragging this number down. We've created a formula that works. Okay, so the shortcut that we're going to try to do is, instead of having to do it every single time, so 20 times in my case could be way more, we're going to try to create one formula that solves all of them. And the way we do that is we think about what numbers are fixed in the equation and what numbers are changing. So for all of these values, the slope and the y-intercept never change. And this is the part of the video you might have to go back and pause a few times. And once we do it, it'll make the most sense. But if I'm trying to create a general formula for this value, we know that the slope and the y-intercept are never going to change. So if you want a number in your equation to never change, put a $sign in between the row, the letter and the number. So we want this number to stay the same, and we want this number to stay the same. And it's going to be the exact same for you. When you make this formula, you're going to put a $sign for both of your I values. That doesn't change this value, but I want to show you what happens when I now click down. So if I do this, and you have to go to the bottom corner and look for that little plus sign. If I now look at this equation, it's using these two values, but it changed the x, okay? Because they're all in the same column. So if I want to change only the x value, go down this row, or go down this column and have these x values change, I don't touch that b value, but that $sign with 3 and 4 keeps those numbers constant. So I can do that all the way down. And that tells me every single expected value, and hopefully you guys find that kind of amazing. Because all that changed in my formula was the x value we plugged in. So we have to plug in a bunch of different x's, and by keeping $signs for the two I values of the slope and the y-intercept, and then dragging down, it's going to change it. I hope I explained that well. That's the hardest part of the project by far. But if you can do that, like you're a wizard. Like Google Sheets is so good for your life, so good for business stuff, a lot of college stuff. So I think that's amazing. That was that. And because we now have the expected values, we're going to now try to find the residuals. We know that for my first data point, we're just looking at New York City again. The data point was 315, and the expected value was 219. So the residuals is this number minus this number. Observed minus expected always. I'm trying to find this vertical distance, right? So if it's this minus this, I'm just going to click them. This number minus this number. And it gave me 95. If I drag it all the way down, it's gonna work. But let's talk about why. And let's talk exactly about what dragging does. So if I drag this down, this equation now is C2 minus D2. But if I want to find C3 minus D3, that's what dragging does, okay? It changes only those values. So C2 minus D2, this one's now C3 minus D3. And you keep going, and it's going to be every single this value minus this. And once you've done this, your project is pretty much complete. You've almost finished. But this is the part where maybe you should go back to make sure you understand. Because again, we found our expected values by using the formula, and then the residuals we know are what happened, the observed values, the data points, minus the expected value to find the residual. All right. I hope that makes sense. I really do. I'm worried because I explained it and it's complicated, but you know, I'm really proud of you guys. Like constantly, really, really proud of you for this because I think it's really cool. Let's do our final thing here, and that's create the residual plot. Okay? And to do this, so we have our final thing to do, and it's going to require a little bit of finesse, but once we have the finesse, it's easy. And we have these two plots. The first plot was x and y, simply x and y, but the residual plot measures every x value and their residuals. But how can I do this and this without this and this, right? That's the complication. We got to highlight this row and this row so that we can do a chart for them, because we know we just want to highlight the two rows. So what you're going to do is you're going to highlight the first one, and then I had to look this up to make sure, because it's dependent on your computer. But if you have a Mac, which is probably like 2 people, which is what I'm using, you're going to press Command after you highlight the first row to highlight the second one. If you have a PC of any kind, you press Control, okay? I'm almost positive. If not, I'm pretty sure you press Control, okay? But Google it, and if you made it all the way to this step, you're so close. But you take your first set, Then press Command or Control and highlight your second set. Once you have the 2 rows highlighted that you want, you're going to just insert a chart, and you've won. You created your residual chart. It already looks perfect for me. It says the residual here, the 2019 population, and let me highlight this residual plot for U.S. cities and air quality. And I'll put it down here. And again, I'm going to talk a little bit about these 2 plots just because this was the hardest part of the whole quarter. But we have our 2 graphs, and now that the video is almost over, I got to be honest, I lied about some of the data so that my plot looked better, which is a typical thing I do. Because in our dystopian world, or the world that, I'm gonna skip that. But what we could look at the residual plot and see, okay, last thing. And now that we're at the very last step, we have our 2 plots, and if yours look really random, that's totally fine. You probably didn't think as hard about the data set working to be linear or non-linear, anything like that. But if I'm looking at my residual plot, my scatter plot, I just want you to notice that something exponential or quadratic or curved probably fits my data better, right? Most cities, US cities, most of the small ones, aren't very polluted, but some US cities are massively polluted, like the really populated ones. And we can tell that this graph is non-linear and in fact would be better with like an exponential by looking at the residual plot, right? Because we see this pattern where the middle of the data set, these points, are below it because the line is kind of accommodating. So again, it's cool if yours don't really look like this, but my project ended up working pretty perfectly. But that's it. You don't have to do it twice. You just have to do something that's harder than the first project a single time. So make sure you get your data first. Finding your expected values and your residuals are going to be the hardest part. But I think we got this. The video is going to be, I think, 20 minutes, so I think that's good. Woo! All right, guys. Love you.